Alright, what's up guys? In this video we're going to pick up some calculus here, and we're going to be talking about series again, more specifically using the ratio test to determine the convergence or divergence of a series. So as to use the ratio test to determine if the given series converges or diverges. So we're given this series here and we need to use the ratio test. So let me just quickly remind you of the ratio test. And this is a very important convergence test to know how to work with, because you're going to be using this a lot, especially when you start trying to find radius of convergence and stuff like that. So you want to know the ratio test very well. So the ratio test, that's just the limit as k goes to infinity. And by the way, it won't always be k. Some books use n, but it doesn't matter whether it's n or k, it's the same thing. So it's the limit as k goes to infinity for the absolute value of a sub k plus 1 all divided by a sub k, and that's going to be equal to L. And remember that the conditions are if the limit which will denote L happens to be less than 1, then the series converges absolutely. So series converges absolutely, and I'll put ABS for absolutely. Remember that if the limit, which we denote L, happens to be greater than 1, or let's say you get infinity, then it diverges. And then remember, if the limit is equal to 1, it's inconclusive, basically meaning that you'll have to use a different test. Now 9 times out of 10, or not 9 times out of 10, if it's inconclusive for the ratio test, it's going to be inconclusive for the root test as well. So just keep that in mind as well. So let's identify a sub k. So a sub k here will be 1 over 5 raised to the k. Also, some professors will give you some leeway in certain problems that allow you to use whatever test you want to use on a series. They may say, well, check to determine the convergence or divergence of this particular series. Use a convergence test of your choice, and a lot of times you'll get to choose. The ratio test is a really good test to use when you have factorials, even though we don't have factorials in here. But it's a good test to use if you want to select your own convergence test of your choice. If you see factorials flying around, it's probably a good idea to use the ratio test. So since a sub k is 1 over 5 raised to the k, then that means that a sub k plus 1 will be 1 over 5 raised to the k plus 1. So what we have here is the limit as k goes to infinity, and it'd be the absolute value of a sub k plus 1 all divided by a sub k. So that'd be 1 over 5 raised to the k plus 1 all divided by 1 over 5 raised to the k. Now remember that dividing here by 1 over 5 raised to the k is the same thing as multiplying by the reciprocal of 1 over 5 raised to the k. So this would be equal to the limit as k goes to infinity, and we'll have the absolute value of 1 over 5 raised to the k plus 1 multiplied by 5 raised to the k all divided by 1, and we'll take the limit as k goes to infinity. Now we could take off the absolute value bars once we do some simplification. So we got the limit as k goes to infinity, and after we do some simplifying, it'll be 5 raised to the k all divided by 5 raised to the k plus 1, and that'll just end up being the absolute value of 1/5, which we know is just 1/5. So this just becomes the limit as k goes to infinity, and again, which would be the limit as k goes to infinity for 1/5 is just 1/5. And so as we can clearly see, the limit here, L, is in fact less than 1, and all you have to do is plug that into your calculator, and you'll easily see that 1 over 5 is obviously less than 1, as a decimal, that is. Yeah, so that's going to be our answer. And since it's less than 1, this clearly converges. So your final answer here, we can say that this series converges by the ratio test. Sorry, I'm at the fit it in there. So that's the ratio test. So I'll do another example. If this one was a little bit confusing and you need another example, I got plenty of videos on using the ratio test. So I'll try to post another example for you guys to see. Alright guys, y'all take care. I will see y'all next time.